Hey everyone, welcome back to another Behind the Hype. Today we are talking about developing an AI model and actually putting it into deployment. I'm Ryan from Finastra, and I'm going to introduce Shireen, our Innovation Director, to introduce our speakers today.
Thank you, Ryan. Hello, everyone. Today, we're really excited to share with you another natural language processing project that the Finastra Innovation Lab has worked on. And for that, I'd like to introduce our speakers today. Ivy, a data scientist from the Finastra Innovation Lab, will be speaking about the model development. And Pierre, who's our innovation principal, and will share with you all the development work that is required for model deployment. Ivy, over to you.
Okay, let's get started. So today we're going to be showing how we developed and deployed a natural language processing model.
Before we jump into that, Ivy, you have another guest to introduce, don't you?
Oh, I do.
And it's worth it.
Aww. Harvey, say hi. This is Harvey. This is my dog.
Oh, bless. Okay.
Okay. Thank you for that, Ryan. Okay, so here's our agenda. We split it into half. So the first half is going to be the machine learning part, where we've got the typical machine learning process, such as feature engineering and pre-processing. And then the other half is how we took a prediction model and then actually used it. So I'm going to give a brief overview of natural language processing. So it's a field that overlaps between computer science and linguistics. And here are some of the most popular forms. And since I have an iPhone, I'm probably most familiar with Siri. Every morning, I like to ask her about the weather, and natural language processing has made this like a really effortless process. Because I have an iPhone, I can just say, "Hey Siri," and then Mike will pick it up and I'll ask her the weather. And I don't even have to touch my phone. So this is completely eliminates the manual labor on my end. Oops. And so the goal of natural language processing is to process things like sentence structures, syntax, and grammar, semantics, things like that, and to interpret how humans talk and then accurately execute certain decisions based on context. So sure, NLP eliminates the need to physically check weather.com sometimes, but there's a whole world of use cases where we can apply NLP. So for example, in the payments financial world, there's a great deal of manual labor that exists, and banking employees have to manually sort and submit pay requests through email. And this can lead to delays in processing times, and people can be a little bit impatient when it comes to the money. So one solution that we made was to use NLP to systematize the text mediums. So this is a little bit about how we selected the algorithms for our model. We use named entity recognition, which is really good for detecting and classifying textual information, such as people and places. So in our example image, the NER can detect that People Magazine is a publisher and Prince Williams is a person. And then we use a conditional random field, which is useful for task-specific predictions. And this is done by assigning probabilities to sequences of text. So here we have Ivy is expected to present tomorrow. And so we tokenize the sentence, which will give us a pot of speeches. And then these purple arrows are illustrations of the conditional independence assumptions that our CRF model performs. And then the two working together gives us a model where we can input text and then output labels. And these labels are important for feature engineering. So this is the data pre-processing and feature engineering process. So our data set was comprised of unstructured email text. And here's a sample email that we generated using a Python library called Faker. and faker just generates fake names and information. So if we look closely at this text, we can see that there's inconsistencies such as spelling and a couple of capitalization errors. This is really common in unstructured data, in unstructured text data. So we wanted to mimic real emails and make them as realistic as possible so that we could have a representative data set. So now we have to select some of the features, and we have a feature vector that has where our features are defined for every piece in the sentence. So some of the features that we used were if a word was lowercase, uppercase, if it's a digit, which is really important for the amount of money that we're looking to label, and then the part of speech, position of the word in the sentence. And this is just a feature vector that shows each feature. And so we can see the word is hello, and the actual word was capital. So you can see it says word is upper is true, which means there's a capital letter. And then word is title means it's in the beginning of the sentence. And so in the email, you can see that these labels here, the account, we wanted to pull out an amount, a currency, and then the two accounts that we're going to be requesting a monetary transfer between. And this is how we evaluated our model. I'm actually going to just show you some live code. So to evaluate our model, we split our data into a training and testing set. And on your first run, the chances are that you're not going to get an optimal accuracy. So to solve this problem and to further refine our model, we use something called hyperparameter tuning. And this is where, so similar to like a computer or your phone where you have different settings that you can kind of configure to the way you like. Similar here where we have settings that we can set. And hyperparameter tuning, we used a randomized search, which means that it's going to iterate through different combinations of hyperparameters to output the best combination of values. So we've got two hyperparameter spaces, C1 and C2, and these are just matrices that have coefficients for the values of the hyperparameters. And then we set a color code for, we formatted the color to go from dark red to dark blue as the results got worse. So we can see that using hyperparameter tuning on our model does not have much of an improvement. But we can see that we get a really good cross-validation score, which is good for evaluating overfitting or underfitting on the model. And in terms of the model deployment, so we saved our model as a pickle file, which makes it very convenient to save and query the model. And then we've got to write a Python class that can handle our predictions. So here's our class, crfner. And then we've got to instantiate it and load it. And here I'm going to show you a live query where we can say, hey, can you please transfer 800 USD from account?
Hi, Ivy. Just quickly, are you able to make your screen just a little bit bigger?
Oh, yes, of course. I'm so sorry. Is that better?
Yep, that's great.
Okay, perfect. So let's transfer 800 US dollars from account this to account, and then it will take out the labels that we want. And that's about it for my side.
Okay, thank you, Ivy. So I hope everyone can hear me well. So we've seen how so far we've been able to get basically emails and sentences and move them from just this is text that I don't necessarily understand into extracting important information out of it. This is the amount, that's the currency, the first account, the second account. That's really good, but how can we make it real? How can we use this model and make it usable from the outside world? Let's say I want to type an email from my Gmail, and I want to be able to have this kind of feature available in my Gmail. So let's have a look at that. So the first thing we have is we have a model. Ivy talked about a pickle file. It's basically like an archive, like a jar when you put pickles. It's the same. You put the model, you close, and it's tight. And it's good because it doesn't take a lot of space. So she can send me the model, and then I can use it afterward. Because we used Python to develop the model, I will probably use Python to extract the pickle and consume it, right? So the first thing I do is I try to find how I can expose this machine learning algorithm using Python. So first step, we'll create a Python Flask server. A Flask server is just basically an HTTP server, or like every time you go on a web page, there is behind a server that's serving it or pushing it to your view. That's exactly what we're going to do. We're going to take this machine learning model, and we're going to expose it via a REST JSON API, or basically a get or post of a URL that we call product. The same way when you go on google.com, you do a get on google.com. In this case, we're going to go a get or a post on my model/product. So the code is pretty simple. I use the pickle compressed AI ML model, and I use Flask to expose the HTTP method. So the first thing I do is I create the port, and I import the file path, which is the pickle file, crf model with currency.pkl. Then I will extract this model and load it. When the model is loaded, I can then call the route saying, if you go to /predict, so let's say google.com/query would work the same way. And if you use a method post or get, then I will do some specific interaction. If you send me data, I will extract the information you're sending me, meaning the email, and I will export and send you as a result what I could extract from this email. So if you go and get post on my server predict, and you give me as an input an email string, I will give you as an output the amount, currency, account A, and account B. So basically everything that you've seen Ivy doing on Jupyter Notebook on the side when she was testing, we can do it now using a REST call. So I can use any client, send an email, and it's going to send me back, this is the amount, that's the currency, account A, and account B. So that's how we expose, using Python, the machine learning model. Now, the next step we want to do is, what are we going to do with this information? Well, thanks to Finastra FusionFabric.cloud, we have open API, so basically objects that we can call, or like web page that we can call, that allow you to do payment initiation. Meaning that if I have the right information, I can send it to an API from Finastra, and Finastra will take care of making it a real-time payment. So the first thing I need to do is find a way to register my application in Finastra and get all the information I need. So let's do this right now. I'm in my web browser right now, and I'm going to explore at the different API that Finastra has to offer. If I go in, let's say, payment initiation, that seems relevant for me. I can have a look at it, and I can see that I have a real-time payment initiation. Then I'm going to create an application, which I will call Gmail initiation. And I can find the API that's relevant for me. So it was called real-time payment initiation. I will validate the end user license agreement, like the things that you have when you open iTunes that you never really read. And now I have my application. Now, the thing when you consume an API is you want to be registered. You want to make sure that the user who is doing this payment is entitled to do it, which is why I have here a client ID. And I can then generate a key, which I will call Gmail. And I will get a secret key. So now I have a client ID, a secret key, and I will need to do the authentication. if I look on the detail of my API, I see I have an authentication and an OAuth with a token URL here. What that means is if I send my information to this token URL, it should give me a token that enable me to use it. So I will need to create two functions in Python. The first one to authenticate myself using the application I've just created here on Finastra's website. And then I will create another call that will then do the real-time payment initiation. I can see in the real-time payment initiation that I have some information here, including amount, currency, account A, account B. Great, that's exactly what I'm having in my Gmail application. So let's use this and create the code. So now that I've registered my application, I'm ready to get credential and start the authorization flow that we call OAuth 2.0. So the first thing I need to do is create an application that will authenticate myself, and then another call or post, or basically an HTTP method again, or a web access to do the post and send the payment. First thing first, the authenticate class. This one will take as an input my client credential, client ID, client secret. And from this, I will receive my access token. So I created an authenticate method that will read the input from a file and then extract the token by doing a call to FFDC and saying, hey, can you give me my token? I'm entitled to do it because I created my application right here. The next step will be then if you go, and I will use again Flask library, if you use the HTTP method payment, then you can give me information like amount, currency, account A, and account B, and the output will be coming directly from the system at Finastra that's taking care of the real-time payment. Meaning that if I post on my server payment, and I give the information from amount, currency, account A, and account B, I can then now create a real-time payment, an actual real-time payment. So by creating this, we already have authentication in charge, payment, and then predict. Now, the only thing we're missing is a UI. And for this, we created a little Google Chrome extension that's allowing, whenever you type an email, to send a call to our predict, and then give you back the information saying, hey, this is what I think is the amount, this is what I think is the currency, and this is what I think are the different accounts. From the UI in Gmail, you can then click and say, okay, this is indeed correct. I want to send a payment. And when you send the payment, it's going to call the Open API from Finastra to create this payment. So let's have a look at this. I'm in my Gmail right now, and I'm going to compose an email. So I want to send $400 from Ivy to Pierre. I just typed this email, and this is going to call my Flask server, check on the Flask server, and come back with the information. The same way when Ivy was showing you the model working, we just implemented the same thing, but using HTTP call and basically a REST endpoint. So I get the amount, the currency, account 1, and account B. From there, I can just validate that everything is correct, and then submit. This is going to do a call to FusionFabric.cloud and send me back that the payment has been created. So in a nutshell, we've been able to create, using an NLP model and a Flask server, all the information we needed to create from just natural language processing into a real application for life, which is I want to initiate real-time payment using my Gmail. Now that's really good, but we see that we need to do some code in the Python Flask server. I need to set some information, and it can be kind of complex to use in real life. If I want to set it to production, or I go to a bank and say, hey, can you use it? They might not be an expert at Flask or at Python. So how can I give this to them in a way that's easier for them to use? And that's when the concept of container is extremely important. A container allows you to remove dependency and publish it anywhere. So what I'm going to do is I'm going to take my code and going to put it inside a container. Think of a container like a virtual machine. It's a small executable that can run by itself, and that's going to pull all the dependency from the web as it needs them. So it will take as an input some configuration, like your client ID, client secret, and so on. But that's all it needs, and it's self-contained. So as soon as I create a Docker container and I have it contained, I can then ship it anywhere I want. Meaning that I have my container, I want to run it on AWS, on Azure, on Google Cloud, or on my own computer. That's extremely easy. I can just use the container and push it forward. Now, what you can do with this as well is we created a little repository that's available for everyone to check, which is called AI Gmail, where I created a little documentation on how to use it. And you'll see it's extremely simple. You can download the code on your computer. Then you set your user ID, access key, and your token endpoint. And then you just type Docker Compose. This will automatically create the virtual machine for you and start it. After, you just need to set the Google Chrome plugin in your web browser, and then you're done. So if we want to look at the code and how it runs, we basically can do the same thing here. I have my code here, and I can simply say Docker Compose up. I'm going to add the tag build to show you how it's built. And when I do this, it's going to create the container for me, and then after I can just send the container wherever I want. So when I do this, you can see that it's downloading stuff from Python, updating the data, putting all the code I need in it, downloading the requirement, and then starting my Python app. The only thing you see from the container is that the app is running, and I can use my Google Chrome extension to call this app. So what we've seen so far is how we can start from a model, using some coding to make it accessible for the rest of the world. And that's really how we create our application here at Finastra, and how we use AI and machine learning and open API to innovate, decouple from core systems. So I think we should start opening up to QA if you have any question and want to understand a bit more about how this works.
Thanks, guys, for running through that. So to ask a question, you have a couple options here. You can either ask in the comments section, or you can ask anonymously using slido.com. So below you should see, you can ask a question by typing in slido.com and using the code HYPE, H-Y-P-E. But to get started with some questions while we wait for them to come in, what were the barriers or bugs that you came across when both creating the NLP but equally deploying it? Was there any new challenges that you faced?
Yes, and I can actually show you something because I forgot to mention it. Let me just share my screen.
Yeah, we've got it up.
Okay, perfect. So one of the challenges was, well, first, we couldn't get a lot of data because of privacy reasons. So we had to generate our own data. And when we generated our own data, we forgot to consider email signatures. So I have an example right here, and this is how we can use our model's flaws to improve the model. So you can see that because we didn't take into account email signatures, that right here, account B is being pulled out as 200, which is the suite number instead of like the actual account here. So to solve this, we've just got to add more data to the data set and add email strings that have email signatures. So I guess what I'm trying to say is, if the model does not work, you can always add more training data to make it better. And that's one of the problems that we had when we first started performing, because we missed things like adding numbers or letters to account numbers, because at first we used all numbers, and then at first we only used US dollars. And so it's, I guess it's trying to be like more holistic and more representative and improving the model at the same time.
Pierre, did you have any when it came to deploying it, or were you quite familiar with kind of Flask applications and Docker containers?
So I was not necessarily familiar with Flask application, but when you know how an HTTP application works, they're pretty much the same. So if we're using Python, I'm going to use Flask. If you're using JavaScript, I'm going to use Express. They do exactly the same thing. You create a route and you expose it, which is all that matters when you basically try to expose REST API from the backend. One thing that was a little bit tricky is to make the UI feel good in Google Chrome. Because basically, I want to be able to send back information and the amount and so on. That's the only thing I get. So creating some color, making sure that it doesn't reformat the text. Because if you're typing in Google Chrome and it starts like calling in the backend every time, and every time you strike something, it just tries to see and rephrase and everything, it's very annoying because you can't type an email. So I had to make sure that it would wait a little, send the information, and tweaking the UI to make it feel good was kind of the harder part.
We've got a question that's come in. How long did it take you from development stage to production? I guess there's two parts to this, because there's what Ivy's done and what Pierre's done.
So the machine learning part actually doesn't take long at all. Like developing the model, what took long for us was generating the data and then improving the model based on the NLP flaws that the model did not pick up. So doing that part generally takes maybe so actually coming up with a machine learning model that works doesn't take long at all, maybe like a week, but getting that to be more accurate, it took maybe like a few weeks after that.
And the thing I'm always impressed when we talk about machine learning is the feature generation. Like, I don't know if you saw, but when she was presenting all the features that we had, you had like, oh, the word that's before, is it a word at the beginning? Is it a word at the end? Is it capitalized? Mm-hmm. What token is it coming from? And for me, that's kind of the magic of machine learning. When I saw the model, I was like, wow, this is so crazy. There is all those different feature. I had no idea. It's so smart to just come up with a feature. And I feel like that doesn't necessarily take time, but you need strong knowledge on what feature are relevant for NLP, for example. And I feel like that was a big learning moment for me here. It's not a question of time. It's really a question of knowledge. So it's a time you spent before creating this.
Right.
And that's how you can make it so fast, I feel. On the Docker side and the Flask application, development is very easy. It's just tuning the UI, making sure that it works the way you want or that customer would expect it to work. So I would say coding is probably 2 to 3 days. And then after you just spend 1 week or 2 weeks going back with the client, making sure that it's something that's relevant for them, that's what they expected, and so on. So it's not a long time in terms of development. It's more a time of validating. Business validation is what takes all the time.
So
sorry, Ryan. Maybe to add on that, actually, another question for both of you. So the demo and what you both presented was quite impressive to see how easy it is to build a model and then to productize it, to expose an API, to consume an API from FusionFabric.cloud. This is all a prototype that we've built in the innovation lab at Finastra. How much effort would it take to productize it? Or if we were to take it in production, what other steps would we need here? Just to give people an idea of what it's really about to build something and take it into production.
So if you want, Ivy, I can take it unless you want to jump in.
Oh, yeah, of course.
So I think the biggest, the product is working, right? Now, what you want to make sure is that it's business relevant. So we know it's feasible. We know it's viable in a way, right? Because we can definitely like sell it. But is it desirable is a real question. And so when you go from a prototype to make it really desirable, that's where it's really tricky. You need to go back to the business, make sure that that's what your client wants to see, and so on. So when we demonstrate this capability, maybe they'll say, you know what, Gmail, no, I don't want people doing it from Gmail. But maybe a good endpoint for me would be to do it from Salesforce or to do it from whatever places that we're using. And that's when it's interesting for us because we already have the backend API and we just need to change the UI place. and that's when you can make it into production. So even when you iterate on a prototype, the failure that you get by, for example, picking the wrong UI is where you can get even broader use cases that are relevant for the customer.
Cool, thank you.
So a follow-up question on that. Obviously, you've done this as a good proof of concept. What's next?
Hmm.
Do you want me to go as well, Ivy?
Yes. Well, I think of a good answer.
Good. Then I'll pass on to you after. So honestly, a very similar question to the previous one, which is what's next is basically moving from a prototype to a production. And this, once again, involves going to our customer and trying to find the right information for them. You can also go to a fintech that say, we want to be able to use an NLP that makes sense when someone type an email, and then we can extract it there. The key message here is that we have the API to generate a real-time payment, and we have the AI capability to understand from real conversation how to create a payment. And this can even be used in a chatbot. Think about it. I could just go and say, Alexa, I want to send $500 to John and from Paul. They already have an NLP in Alexa, but instead of retraining a model, we can just use this directly. So it's really not only a prototype to show what can be done, but also to start idea from our customer so we can generate a product that's relevant for them again. Does that make sense? Is it like kind of what you were expecting?
I had no expectation apart from amazing stuff from you both.
Ivy, do you have anything you want to add?
Well, I just wanted to add that because we developed this as like a proof of concept, so we wanted to show that a concept works and that we can apply it to the real world, right? So I think that if we were to further like pursue this project, we would probably try out like maybe different algorithms or different methods of hyperparameter tuning, or just like a bunch of different ways that we can try to improve the model, or maybe not even pertaining to this project, but for other projects, we can show and develop more proof of concepts of how we can use NLP to make life processes more efficient.
We've also got another question. I think that's for you, Ivy, about the training set. How large was the training set that you've used for this model?
I think so. It started off as like maybe like I know it's in like the tens of thousands of email strings, but we were just constantly like regenerating data and adding more to the data set. So it's pretty long. It's I think like maybe 20,000 or more, 15,000, something like that.
Shireen, you're on mute.
Yeah, sorry. So I think we have a couple of other questions, and then I would have yet another question for the speakers. So another question that we've got is about performance testing. Have you done any performance testing, especially if you have millions of records to validate the source and destination of transfer?
So that would be more on the making it production, right? Like, have we tested the performance of the REST APIs that are being called? Honestly, no, because for the prototype, we didn't need to. Now, the good thing with Docker, again, and the fact that we use a container, is that it's really easy to just spread it into a lot of different cloud containers. So as long as I have a load balancer in front, those are independent requests. Giving you an email string and getting the amount, the currency, the currency, the account A, account B. If I have a lot of different containers running, or one, it doesn't matter because it's sessionless. It's purely RESTful. So if I send a call, I get an answer. As a result, being able to make it run in a lot of containers and scale it is extremely easy. Once again, the Docker gives you scalability. Now, the other part is calling to FusionFabric.cloud API, and those are already proven to be able to scale.
So I've got some more questions. So for third-party app builders, can it be sold as a Finastra application to avoid the need for a new vendor procurement onboarding at the customer side?
I'm not sure I understand the question exactly.
So I think this actually links probably more to FusionFabric.cloud, and if you're building an application using FusionFabric.cloud, I guess how do you leverage the fact that there is a marketplace for apps, which we haven't touched upon in this session, but I know you're very familiar with it.
True. So basically, when you created an app and use the Sandbox API, which is exactly what I did. You remember I created an app live on our website. It's not I registered an app to get a client ID and a client secret. And from there, I'm able to call our Sandbox API. Now, the Sandbox API are the same that the one our production API at our customer. So what we need to do, if you have an agreement with our customer, we just move from this tenant to the production tenant, meaning that the cost of development, again, the Sandbox, if it's ready and it's been validated by our team, we have a team of experts and an external, actually, company that does the security and the audit, then we can easily move towards the production tenant. That means that your application can be used directly by our customer.
So we've also got a session coming up this week, which goes into that journey a bit more in terms of the detail of it all. So I will make sure in the follow-up that I send a link around to that if you want to hear more about how do you get an app into our marketplace. We have another question, which maybe Ivy, you want to answer. Do you know of any ML benchmarks for the finance industry?
Benchmarks? I would definitely say chatbots. I think if I'm interpreting the word benchmarks like the way that you intend, but chatbots definitely, because like when you open the Bank of America app, you can chat with Erica, or I think a lot of people use it on like banking websites. Let's see. I'm drawing a blank right now, but
well, we've got another question, which is around how do you handle misspellings or typos in the email?
Oh, so actually, I don't really think we left the spelling errors in there because everything else. So in the presentation, let's see. So we left small spelling errors like this. We would do things like abbreviate account and try to like mimic some slang that's used in the English language and stuff like that, just to make sure that our model trained and was able to not pick that up. So we kind of just left the errors in there, but we definitely also had emails that were grammatically perfect. We only did this so that if, for example, if someone instead used account spelled out instead of ACCT, that it would still pick up the next account label, if that makes sense.
Mm-hmm. We've also just had a clarification on the previous question. So it's about benchmarks for model accuracy.
Oh, so for this project, we only used hyperparameter tuning and then just like F1 score for accuracy. But I mean, let me think. I don't know if if benchmarks is really the right word to use. I don't really, in the financial world, I guess, because I mean, as in machine learning models, when we use like benchmarks or anything for accuracy, we are using it on the model, but I think not exactly. I'm sorry, this is a really bad answer.
I think it brings about the point that actually for each of the projects that you're doing, it's quite hard to benchmark exactly, because they can all be so different from when you jump from, say, payments to a lending AI model, etc. A question on, I don't know for Pierre, if you wanted to add anything to that.
No, makes sense. I think what we can do also is we can go with the AI team and try to come up with like the different benchmarks that have been used around it. It's true that for NLP, benchmarking is much harder than for like transactional data or something like that, because you have much more amount of data. Whereas NLP, it's more, hey, someone said something about payment. So it's harder to benchmark, pretty much.
And actually, probably there's not much benchmark data available on that is specific to the financial services industry. I think it's probably one of the biggest challenges that fintechs are facing today. And maybe another note to FusionFabric.cloud here, where we've recently added some data sets that are available for developers on the platform, and we'll be adding more and more to that. So, but it remains one of the pain points for fintechs today.
Cool. So a last question from me. You've spoken about a number of things about NLP, Flask applications, Docker containers, Pickle, etc. What would be kind of your advice, or if someone wants to learn more about it, are there any good resources that you would point people towards to build up knowledge and practice?
In terms of machine learning, definitely I would recommend Medium. If you're ever stuck on like a machine learning concept or coding problem, there's a Medium machine learning article for everything.
You can also download our code from GitHub with Gmail, and you can look at it to try to understand better how it works. I think that's a good start. We can probably send the link afterwards to the attendees. I mean, the code is open source, it's free, so you can just play around it. You can understand, oh, that's what Flask does. That's the thing they were talking about. It's a good way to do it. Another thing is just stupidly Stack Overflow, or just like finding online resources around it. There is also very cheap online course that you can find on AI and ML that are very relevant here. Usually the issue with that is they stick you to one technology. They say, oh, this is a TensorFlow class, so you're going to learn Google technology, or this is PyTorch, and you're going to learn only Facebook technology. So it's important to have multiple things in your toolkit. In this case, we use, like, for example, a Scikit NLTK, which is the natural language tokenization that's coming from a Scikit package, which is not PyTorch, which is not TensorFlow. So it's important to bring your knowledge around it. So just be curious.
Cool. Thank you so much, guys, for running through that. It's really nice actually to see live demos as well of how things are working. Also to meet your dog, Ivy, Harvey, if I remember correctly.
Is he here?
Is he coming back?
Harvey, come here.
So while you bring Harvey back, we have, we continue to do Behind the Hypes. We've got ones most weeks, so we hope you join us again. Definitely going to make Harvey full screen. Isn't that a nice way to end?
So cute.
You could see my other dog in the back sleeping.
I think every time we do a Behind the Hype, we should now introduce dogs. That's a new rule.
I like that.
Thank you all. Goodbye and have a great day.
Bye, everyone.
Bye. Thank you, everyone.
Thank you. Bye-bye.